Quantum mechanics is a set of physics theory describing atomic scale phenomena, based on some assumptions that might look to be strange from a classical point of view. However, quantum mechanics provides us a very good understanding on how the world works in a microscopical scale with just a little bit of mathematical skills. In my university, they provide quantum mechanics course to junior students who major in physics. However, as I was saying, quantum mechanics require just a little bit of mathematical skill, which is some linear algebra. So I think maybe we should and we could learn it earlier, and maybe I can provide this course to a broader range of people than just a junior student who major in physics. So I made some adjustments on the course to make it suitable for high school level, which means that whenever you are a high school student, or you are some people majoring or focusing on some irrelevant area, you will be able to understand what I'm going to say in this series of videos. So in a word, what I want to say is quantum mechanics is not as hard as you might think about it. And after the learning of quantum mechanics, you will be able to gain a whole new life-changing picture of the world. So, quantum mechanics worth a try. Well, if you don't mind, let me be your guide to the marvelous journey to quantum mechanics. If you are going to travel in a huge metropolis, say London or Beijing, the way a wise local guide might take is like this. He or she will show you several most interesting spots in the city to give you a brief experience, a brief impression of the atmosphere in the city. And then he or she will give you a map to let you explore the rest of the city all by yourself. And this is exactly what I'm gonna do in this series of videos. In this series of videos, I will discuss some core concepts and structure of quantum mechanics. And then I will give you some tools to let you have your own exploration of quantum mechanics. And in case some of you guys might need some kind of maps, I would recommend several books and a series of videos to you. The first book that I would recommend is The Principle of Quantum Mechanics by P.A.M. Dirac, who is a quiet Englishman and who is also one of the greatest enlighteners of quantum mechanics. And this book was written in 1930s, but it is still one of the most greatest quantum mechanics textbooks today. And the order that this book telling the story of quantum mechanics is similar to the order of this series of videos. And P.A.M. Dirac likes to write his story about his books in a way that is very clear, logic, and he will use a very elegant kind of English to write the story of quantum mechanics. And one of the Nobel Prize winner, the American Chinese physicist C.N. Yang comments on the way that Dirac using English as is an old Chinese saying. This is C.N. Yang used an old Chinese saying, 秋水文章不染尘, to comment on the way that Dirac using English writing science. And if you know Chinese, you will know what does this mean. If you don't know, I don't know what to do because it's very hard to translate. And so anyway, I recommend you to read the whole of these textbooks because Dirac telling the story of quantum mechanics in a very good way. And the second book that I would recommend is also a textbook of quantum mechanics, which is Introduction to Quantum Mechanics by David J. Griffiths. David J. Griffiths is a modern American professor, and he writes his book also in a very American way, which means that he is using a very verbal kind of English language to tell the story of quantum mechanics, and including a lot of jokes, a lot of personal style language, and he tells the story of quantum mechanics in a slightly different order. And I would also recommend you to read this book. And the third book that I would recommend is Quantum by Manjit Kumar. It's not a quantum mechanics textbook. It is a book that telling the story of the developmental history of quantum mechanics. It tells a lot of story that happens on the historical time, historical period that quantum mechanics was born. And if you are interested in that part of history, that part of quantum mechanics, that is a good book for you to read. The last map that I would recommend is not a book. It's a series of videos. And you can find this series of videos on YouTube. The name of this series of videos is Essence of Linear Algebra. The name of the uploaded, 3 blue, 1 brown. This is not a very long series of videos compared with those linear algebra textbooks. According to my own experience, most of the linear algebra textbooks are boring and hard to read. However, this series video provide us a very vivid way to tell the core concept of linear algebra, which we will be using a lot in the mathematical structure of quantum mechanics. So I would recommend you to watch the whole series of video, and the name of the series of videos is called Essence of Linear Algebra. Now I'm going to introduce you the basic structure of this series of videos. I divided this series of videos into 3 major parts. The first one is introduction, which we are in now, and the second chapter is foundations of quantum mechanics, and the last chapter is mathematical structure of quantum mechanics. And in the first chapter, introduction, which we are in now, I will give you an overview of quantum mechanics first, and then I will tell you a little bit about the history of developmental quantum mechanics. And after that, we will have some discussion on several experiments. And then we get into the second chapter. In the second chapter, we will have some discussion on the basic assumptions of quantum mechanics, among which the most important one might be the principle of superposition of states. And in the meantime, we will have some discussion on some basic concepts that we will be using in quantum mechanics, like states. And after this, in the last part of the second chapter, we will have some discussion on several comparative interpretations of quantum mechanics. And about this part, I also have you a map to recommend to you, which is a book, this book, Philosophy of Science. Written by Samir Okasha. By Samir Okasha. This is a book about philosophy of science, and in several chapters of it, the Samir Okasha discussed something about realism and anti-realism, which we will be using in the discussion of the several interpretations of quantum mechanics. And the last chapter will be mathematical structures of quantum mechanics. And in the beginning of this chapter, I will introduce you a generalization of vectors. And then I will introduce you Dirac notation, which contains cat and mouse, which correspond to states, and then operators which correspond to dynamical variables or observables, and something else about the Dirac notation. And I will also tell you the relationship between mathematical structure and physical result, a physical experimental result. And after this, I will tell you a little bit about the evolution of states. And this is the basic structure